Good afternoon, everyone. Good afternoon. Hope all is well. Hope everyone's doing all right. So we're going to wait a few seconds to let everybody get connected, and then we will get started. All right. So good afternoon once again. Hope everyone's well. Hope everyone's doing all right. So today we're going to do one. For one might be short. We might just do two sections. We're not going to do all of chapter 4 today. Just wanted to do something because in the summer we don't have the luxury of not doing anything. But at the same time, I still want to give you room to get chapters 1, 2, and 3, or get to a decent place in chapters 1, 2, and 3. Because once we're done with chapter 4, then that would be a whole nother, block of content that you'll be held responsible for. And, you're talking about test 2 because you got 3 and 4 that's on test 2. So trying not to do too much, but chapter 4 is relatively short. So I'm going to push it so that we're not doing it all in one day or whatever. So we'll do one section at the most, maybe two. And then, see if you guys have any questions on anything prior, whether it be chapter 1, 2, or 3, and call it a day. So, but let's go ahead and get the lecture out of the way first. So here we have 4.1, visualizing variability with a scatter plot. So a scatter plot is a primary tool for examining two variable relationships when both variables are numerical, and each point represents one observation. So here's an example of a scatter plot. And you have these points that we will be graphing, and we'll be able to graph whether it be through MathLab or using the app or something along those lines. But each point represents observation. So you'll see what I mean. When we put some numbers on it, get into an example, you'll see what we're talking about. Of course, if I ever scroll up too far, someone's still copying, let me know. When studying scatter plots, we look for trend, which is considered the center, strength, which is the spread of the data, how far, these points are spread away from each other, and then the shape, which is the shape. All right, so the first one, trend. Trend is the general tendency of the scatter plot. As you scan from left to right, you always read it from left to right. Increasing trends are called positive associations or positive trends. Decreasing trends are called negative associations or negative trends. So if it's a positive trend, as you reach from left to right, it's going up. We got some diagrams down here, just giving everybody a chance to write. But negative negative associations, as you read it from left to right, it goes down. Or follow the graph from left to right, it goes down. All right, so here we have 4 generic examples of what it means to be a positive association. So here, notice as we go from left to right, it goes up. So it's positive. Here, from left to right, the pattern is going down. For this third one, there's no trend at all. And then here you see we have a changing trend. It goes down and then it goes back up. Any questions so far? Can you scroll up? All right. So next one is strength. So weak associations result in a large amount of scatter. Talking about scattering of viewpoints. Large amount of scatter means that points have a great deal of spread in the vertical direction. And then strong associations have little vertical variation. So here generically, try to emphasize that, it was data or the points were spread out more. So that's considered a weak association. And here our points are closer together. So that's a stronger association. Okay, let's scroll up. All right, last one, shape. The simplest shape for a trend is linear. Key word in linear is line. So we're looking for patterns that give us a straight line. So linear trends are quite common in nature. They always increase or decrease at the same rate. Last statement, they are called linear because the trend can be summarized with the straight line. So see, we have a linear trend, example of a linear trend, then a non-linear trend, then also another linear trend. One is going in a positive direction. Third one's going in a negative direction, negative trend. And our last statement in this book focuses on linear trends. Any questions? Any questions? So that's it for 4.1. Let's see, how long is 4.2? Yes, we can go now. All right, so let's do 4.2 and then call it a day. So we're looking at measuring strength of association with correlation. Now I'm about to go to another page in my notes. So you can just copy down the title and then we'll go there. All right, then go to the next page. Everybody good? So we start here with the linear correlation coefficient. So the correlation coefficient is the way we measure strength and direction of the linear relation between two quantitative variables. Remember before when we talked about notation, you can have notation for population and then different notation for your sample. So the population correlation coefficient is Greek letter rho, kind of look like a P, like kind of like the Philadelphia Phillies P, but that's Greek letter rho. And then lowercase r is the sample correlation coefficient, which is the one we will be using. All right. So just like we did with the variance and the standard deviation, we're doing, we want to use an app, website, or calculator, something along those lines that will enable you to calculate the correlation coefficient, which is coming out of 4.2, and then the regression line, which is coming out of 4.3. Easy calculation, you calculate them both. I'll show you an example of that in a second, but you do want to have something that can calculate it for you. You're not expected to have to calculate that by hand. All right, let's look at a few properties of the correlation coefficient. So first is between -1 and 1 inclusive. So that means it can be 1 or -1, but it will not be greater than 1 or less than -1. If it's equal to +1, then a perfect positive linear relation exists. If it's equal to -1, then a perfect negative linear relation exists. All right, the closer R is to +1, the stronger the evidence of a positive association. And the closer R is to -1, the stronger the evidence of a negative association.
Excuse me, Professor.
Yes, sir.
I was just wondering, is it because on the on my lab, it's no test for chapter 4 and 5 yet. Is that something that's gonna get added later, or
Yeah. Mhm.
okay?
So you only posted one. I've only posted one for 1 and 2.
Okay, all right.
Yep.
So that's something that'll get added as you do the lectures.
Yes, sir. Mhm.
Okay, thank you.
Yep, no problem. All right. Any problems? Scrolling up a little. All right, number 6. If R is close to 0, then little or no evidence exists of a linear relation. So notice the statement in red, R close to 0 does not imply no relation, just no linear relation. Yep, that's not a problem at all. It's not a problem at all. All right, can you scroll up? So last 2 points, it is unitless measure of association. And then also it's not resistant. So that means it is affected by outliers. All right. So next we just have some generic scatter plots and comparing them to what R would be equal to and what it would mean or how it would look, generically. So the first one, we talked about a perfect line, perfect straight line. That's R equal to +1 going into positive direction. And then as you were to have more variation in your points, then your number would move further away from 1. So here we have relatively close points, but they're not in a straight line, so it's 0.9. And then as that spread increases, those are getting closer to 0, so that's 0.4. Same thing happens in the negative direction. This is a -1, perfect straight line. And then as you tend to spread out as your points start to spread out, you're getting further and further away from +1. This sixth one, R will be close to 0, but there's still a pattern. It's just not a linear pattern. And we said that just because it's not linear doesn't mean that it doesn't have a pattern necessarily. It's just not linear. And then here, R is close to 0, and there's no pattern at all. No pattern at all here. One second, let me get my charger. All right, anybody still copying before we go to another page? Should we okay? All right. Almost finished. So here, correlation does not mean causation. So do not conclude that a cause and effect relationship between two variables exists just because there is correlation, no matter how close to positive one or negative one that correlation may be. Just because there's a strong correlation does not mean that there is a strong cause. All right. So talking about an example that relates to what we just mentioned in black, a politician wants to close down liquor stores in the city because there was a positive correlation between the number of liquor stores in the neighborhood and the amount of crime. And so we have a statement that there's a rebuttal to that. Just want to make sure everybody's done with the black before we move on. All right, so even a correlation near positive one is not enough to conclude that changing one variable, liquor stores in this case, would lead to a change in the other variable, which is crime. So you cannot assume that just because liquor stores are in a space that crime is going to be high, or that if you were to remove liquor stores, that crime would be lower because the liquor stores are now gone. Different things play a role in that. You talk about gang activity, you talk about shopping areas. You can a lot of things add to the existence of crime in a certain place. It's not just liquor stores. So correlation is not enough information to say that there is causation. But what it does is that it leads you into a direction that you can start doing research on. Mhm. You gotta hold on to it. All right. So correlation coefficient in context. The correlation between the number of Google searches for zombies and vampires is R equal to 0.924. So anybody hold on to the red up top? This means that those who Google search zombies also tend to search vampires because R is positive and close to 1. So that's the correlation there. Because it's 0.925, 924, which is once again very high, it's close to 1, and it's positive. It means that those who search zombies normally tend to search vampires. If it was negative 0.924, that would suggest those who tend search zombies do not look for vampires, do not search vampires. All right. So now we'll talk real quick about finding the correlation coefficient. Here we have the club head speed of a golfer and the distance the ball travels. So you're talking about swinging a club or a golf club, and when you connect, the distance that the ball travels. So that'll be miles per hour for the golf club head speed, and then the distance will be in yards. Anybody hold on to the red? So notice in green, I have an explanatory variable and response variable. We're going to talk more about that. I think that's in the next section, but we'll talk about the difference between the two. We'll just give you a heads up. Club head speed in this case is going to be our explanatory variable, and the distance will be our response variable. So here we have 8 different occurrences, even though you see 16 numbers here, but this is one occurrence. I swung the golf club at 100 miles per hour, the ball went 257 yards. And here's an occurrence, all of these, this is just 8 occurrences. How fast you swung the golf club and how far the ball traveled, all of them are, they're one occurrence apiece. Or observation piece. That's the observations. Can I go to the next page, show you how this works in easy calculation?
I'm still copying. Just one more
Too
minute.
late, too late, too
Oh,
late. No,
sorry,
I'm
sorry.
just joking, I'm just joking. It's not a problem.
Thanks.
Uh-huh.
Okay, I'm good. Thanks.
Not a problem at all. All right, so we're gonna do correlation coefficient and easycalculation.com, easy calculator, easy calculation, just like I did with standard deviation. You type what you're trying to find first and then put easy calculator behind it. That's if you want to use easycalculation.com, but this is the first one, correlation coefficient. And then from here, we can add rows. Or if we want to take them back, we got to add one. So, all right, so. All right, so just hit calculate. Notice it says 8 numbers or 8 observations, and then here's our correlation coefficient. So MATLAB may ask you for 3 digits, may ask you for 4 digits. Just make sure you round to the place value that they ask you. And then also be careful here. Make sure you go back and look at your data set and everything, because if I change this to 274 instead of 275, notice I get a different number, 93107. Where 275 was our number, so we got 9380869. So you will get a different number if you just mess up on 1 digit. So always make sure you go back and take a look at what you've done before you type in your answer into MATLAB. All right, so before we go any further with the notes, is everybody okay with what I did here? Make sure you're all right. Okay. And that's all we have right there. R is equal to 0.9387. That was based on what we just did. All right. Questions on anything?
Okay, so the 8 observations, or so there were.
Was that for me? You just talking to yourself?
Oh.
Okay, you didn't.
You know what? I didn't realize.
Okay.
I wasn't muted. I'm sorry. I talk to myself all the time.
It's fine.
Thank you. Sorry about that.
You're fine. You're fine. So let me look at some. I'm gonna scroll back up, guys. Give me one second. I was looking for something. I know it's somewhere. Let's go back. Yep. There you go. Okay. Sorry about that. I just wanted to be clear. I thought it was somewhere. It's a little further down. So talking about this explanatory and the response variable stuff. Just a little further down. Just make sure I didn't miss it. All right. So that's it for 4.1 and 4.2. Questions on anything I've said up to this point as far as chapter 4 is concerned? Is everybody good on that before I go anywhere else? All right. And I know some of the stuff, questions probably won't come up until you get into MATLAB, and that's understandable as well. Any questions on anything from chapters 1, 2, or 3? We know that we've covered those or that amount of content so far. We just added a little bit out of chapter 4. And for those who may have came late, I'm not going to go any further in the lecture because we got plenty of time. But when it comes to the summer, you don't have the luxury to not do nothing a whole bunch of times, but we do have to do a little something. So that's why we went ahead and knocked out 4.1 and 4.2. But I do want to give you guys an opportunity to get in a good place with chapter 1, 2, and 3 before we before we know it, we'll be in chapter 5, almost looking at chapter 6 type stuff. So I'm trying to give you guys an opportunity with that. Any questions? Any questions?
I have a question about doing the box plots and the quad trials.
Okay.
So my problem is that copying down those huge long lengths of numbers and then trying to put them in order from least to greatest.
Okay, is there a problem that you're talking about, like specifically in math lab?
Yes, give me 1 second, see if I can pull it up.
See if I can help you out with that.
So section 3.4
Right.
and the homework, like question 1. I know that's not a difficult question, but I have spent an inordinate amount of time on it because I somehow can't seem to, I either miss numbers or like, is there a simple way to somehow arrange all of those numbers in from least to greatest without missing any of them?
Now, you sure it was number 1?
Section,
So 3, 4, number 1.
sorry. How about sections? Oh, section 3.3. I'm sorry.
3, 3. Okay. Yeah, no problem.
I'm in the wrong spot. Like questions 3 in section 3.3.
3, question 3. There we go. Okay, I'm with you now.
Like, I know how to do what it's asking me, but I'm struggling because I just am having a really hard time like getting all of those numbers organized from least to greatest without missing some numbers, or like, is it supposed to be that labor intensive and I'm just missing a trick?
Let's see, because we can open it up in Excel. Let's see. Trying to open it up and see if it's just as easy as that. Give me a second. Okay, yeah, we can do it like this. All right, so let me show you what I'm about to do. So right here, you can click this right here and hit open in Excel.
Oh.
All right. So you can see the screen, right?
Yeah.
Okay. All right. So now let's go to Excel. Let's go to my way. Hold on 1 second. All right. And I can take this and sort it. Let me see data. I can sort right here from smallest to largest, or I can do from largest to smallest. You see that?
Okay.
That. I guess we can do both of them. Let's see. All right. So
Well, that is significantly easier than me like writing all those numbers out by hand and then like crossing them off as I put them in order. So.
Right. So that's one way of doing it. Yeah.
Okay.
and then
I
you
was
should-
like,
yeah.
it should not be taking me 1 hour to keep getting the wrong answer because I'm missing stuff. Okay.
And if you look in here, you may be able to do other stuff too. I just haven't played around with it much, but at least that's how you can get your sort.
Okay. Good. Okay. I don't know anything really about Excel, so I can probably manage this.
Yeah. So, and if you you have any questions, feel free to reach out. We have to meet outside of class time and go through some stuff. Then that's fine. Mhm.
Okay.
Oh, okay. Yeah. Okay. I see what's going on. Okay. Yep.
Okay.
So is that all you needed so far?
Yep. I was like, I'm missing something. I know this cannot be like, yeah. I was like, this is definitely operator error going on.
All right. Well, just most definitely let me know if you need anything else. Anything else? Anybody else? Anybody else?
Yes, hello. I just want to know, do we need to make an appointment with you if I need to speak with you like outside of class online? Because I
No, we
did go
changed.
into your,
Okay. Good.
I'm sorry, I did go into the email. I do see that you have like open days for
Mhm.
us to reach out to you. So do I need to make an appointment with you first?
No, you can just come there now. If you know you're going to be like super late, let's say like because I have 2 hour blocks set up. But if you know you're
Okay.
not going to make it to the second hour, then I would ask that you kind of
Mhm.
like shoot me kind of like an email. I'm coming, but I wouldn't be able to get here till like 3 or whatever the time is because I'll sit there for about half an hour. Don't know nobody's show, and I'll probably go do something because I'm just sitting at the house doing stuff. And I'll try to be monitoring it. But if you know for a fact that you're coming and you're gonna come late, just shoot me an email, let me know that you're coming, and I'll be there at that time.
All right, no problem. Thank you so much.
Yeah, no problem. All right. Anything else? Anybody else? Anybody? Okay. So you guys are good. I'm good. Take advantage of the time. Of course, class ends at 3 or 4 or something like that. So we really have more class time. But I'm trying to give you guys opportunity to knock out this math lab stuff. Excuse me, without a whole bunch of other stuff being thrown at you. So once again, take advantage of the time. Let me know if you have any questions.
I do have another question. Sorry.
Yes.
Do you have a suggested timeline of when, you'll be done with chapter 4 and like how far after that we should plan on taking the test? Obviously it's, self-directed class, but like if this was in a classroom, you would be like, yeah, within like a week or 10 days, or don't go longer than this without going ahead and taking the test. And
Yeah, I would say, a week is, that would be out, because what you don't want to do is just have stuff lingering out there, and then next thing you know, you forgot what you've done and all that type of stuff. Yeah, so we're gonna close out chapter 4 next class, because there's only 2 more sections of chapter 4. And so that test will probably just be another test that you do on your own. Chapter 5, chapter 6 test, because at some point I have to proctor a test. So chapter 5, chapter 6 test will probably be proctored, but I'll give you options on how we're going to do that as well. So we'll talk about that when we get there. But I'm probably going to I will post 3, 4 tests after next class. And then, I would say in about a week, you want to go ahead and knock that out because, chapter 5 and chapter 6 are coming as well. I'm probably going to give a day where we can just come in and ask questions. So that probably will be next Monday, where you can just come in and ask questions. I will not do anything new, but that's because, we're at that point, because I can't do that for so many times because of summer school. But next Monday will be, as long as we're able to finish out chapter 4 next class, next Monday will be just a review day where you just come in and ask whatever questions you want. So, And so that also gives you a little bit of a buffer to get this other stuff done before we jump into another chapter.
okay, thank you.
Yep, no problem. All right. Anything else? else? Anybody else before we close? Make sure we do it. All right, so guys, if you're good, I'm good. You know what you got to do. Next class, like I said, we'll finish off chapter 4, and then I'll send you off into the weekend. All right, so you guys have a good one. Be safe, and I will see you next class.
You have a good day.
Thanks. You do the same. Take care.